So today we want to solve some problems, okay, and we can, explain the parts or make review on, on some points. يعني. طيب, find a spanning set for the subspace W. So this is a subspace. طيب, لما يكون عندنا a vector space like that, what is a subspace? إذا كان ده vector space. طيب, if we have, this is a subspace, let's call it W. Okay, he told me that this is a subspace. And its element, they look like what? X plus 2x, this is the first element. X1 plus 2x2. و correct. اللي هما, sorry, this is اللي هيكون عندنا yeah, x1 plus 2x1 2 و the second one 3x1 minus x3, and this is, and this is, okay. So x1 plus 2x2 and then 3x1 minus x3 و 4x2 plus x3 و here x1. This is how the elements here they look like, such that xi belong to R of R4. Yeah, I am في R4 ليه؟ لأنه عندي 1 2 3 4. So عندي 4 elements. Okay, now we want to find a spanning set for this. What is the spanning set? We said before, if I have some elements, okay, from this vector space, if I can do a linear combination and find all the other elements by doing linear combination of these elements, correct? So this space is what it is, a subspace. Okay, so he showed me how the elements here they look like. كيف الاليمنت هنا شكلهم. Okay, اللي هي like this. طيب, and he want me to find what? To find this element that they what? Span this space, that they generate all the elements here. Before we used to have examples like that, فبدل x1 و x2 كان بيقول لي a plus مثلا 2b, correct? وهي 3a plus وهكذا, correct? So it makes no difference to call it x1 or x2, x3, or to call it a or b or c. So what I'm looking for these elements that they span this space W. And to do that very easily, I can write this vector like what? Addition of some vectors, correct? Type. So for x1 first, اللي هي هيكون عندنا شنو؟ عبارة عن x1 and then 3x1 and then 0 and then x1. This vector plus the second one اللي هو 2x2 and then 0 ما فيه x2 هنا and then here plus 4x2 and then here 0 ما في x2, correct? And then plus the third one related to x3 في شنو? Here there is no ما في terms few x3 0 and then here minus x3 and then here plus x3 and then here 0. take the x1 as a common factor from this vector. صح? Addition of these vectors, it will give me this one here, correct? طيب. Okay, and now if I take the x1 as a common factor, so it's going to be x1 multiplied by 1, 3, 0, 1 plus x2 multiplied by 2, 0, 4, 0, and then plus x3 multiplied by 0 minus 1, 1, 0. Okay, what is this? So this is the linear combination of what vectors? This vector and this vector and that vector. Because x1 and x2 and x3 are real numbers, like the c1 and c2 and c3, correct? يبقى what? يبقى my space is spanned by which vectors? هيكون spanned by two vectors. This vector and this vector and that vector. Yes? يبقى what is the spanning set? It is I can write the vectors like that, okay? So this set, يعني S is the set of vectors what 1 3 0 1 وهكذا. I write them, and the second one 2 0 4 0, and the third one I write it and then I close the bracket like that. So يبقى W, the subspace W is equal to span S. It is spanned by the set what? By the set S. Span S. Where S is what set? Which set is this set? Actually, he asked me to find this set. Is it clear? Or there is a question? Clear?
Yeah, clear.
Right. Now, this one. Let S is equal to V1, V2, V3 be a basis for a vector space V. طيب عندي set, عندي vector space V. This is a vector space V, and it is generated by what? 1 2 3 spanned. عشان ما يكون عندي basis, أي basis has two شنو؟ two things, has to satisfy two conditions. The first one is that the vector V, vector space V, is spanned by this set S. يعني this set can generate all the space V by doing شنو? linear combination for these vectors. يبقى هنا عندي 3 vectors, they can span all this vector space. يبقى الفيكتور سبيس الدايمنشن حقه كم؟ 3. احنا مذكرين في R3 قلنا any 3 linearly independent vectors they can generate مثلا R3. So here, since this is a basis, يبقى this space الدايمنشن حقه شنو؟ 3. Okay. Now, he asked me to determine if these new vectors are bases as well. طيب ديل هم bases. فهل these new ones are also bases? That means they can generate this vector space as well or no? طيب. What we said before. احنا قلنا الدايمنشن حقنا 3. طيب these are 3. 1 2 3. Okay. هل هم linearly independent or no? يبقى remain. احنا ما قلنا two things. Sorry, I didn't mention the second part. المفروض يكون يعني معناها these vectors الثلاثة ديل they span the space and they are linearly what? Independent. Correct? Any basis عندهم two conditions. They span the space and they are linearly independent. طيب here we have 3 لأنه dimension 3. Okay, already I have the 3. The second question, is that they are linearly independent. If they are linearly independent خلاص definitely they will span the space V. طيب طيب how we can find that they are linearly independent ولا لا؟ أخذنا. How we can find that they are linearly independent ولا لا؟ Can I use the determinant؟ الرول بتقول لي if the determinant is not equal to 0 then they are linearly independent, correct? But I cannot لأنه عندي V1 و V2 V3. How I'm going to calculate؟ ما في أي information to calculate the determinant. يبقى the other thing is that how we can know a theorem. الست بتاعت الثيورم we say that let C1 في الفيكتور الأول which is 2V1 this vector plus C2 في ال other one اللي هو شنو؟ في السكند one اللي هو V1 plus V2 plus V2 plus C3 في third vector which is V1 plus V3. We let it or we assume that it is equal to 0. Okay, if it is linear, if it is basis, we said that we have to prove that it is linearly independent. Type to prove that it is linearly independent, we have to check the values of the C's, C1 and C2 and C3. If the value of these constants are all equal to 0, then this implies what it is linearly independent. Correct? Type I don't have any information regarding ال V1 صح وال V2 wow. So how can I go? هل في any information I can use? Yes. He told me that these vectors here are bases. That means any constant, any real number, let's call it K1 times V1 plus K2 في V2 plus K3 في V3. If it is equal to 0, then this case, all the case should equal to 0. طيب يبقى now my aim what? Instead of having this like that, okay, اللي هو عندي common factor C1 و C2 و C3, what? I will make the opposite. I will take all that has V1, okay, together and put it as a common factor later. يبقى هيكون عندي شنو؟ 2 C1 V1 plus you multiply. So C2 V1 plus C2 V2 plus C3 V1 plus C3 V3. This is equal to 0. Now we take those who has V1 together and this one as well, correct? يبقى هيكون عندنا شنو؟ and take V1 as a common factor. هنا V1 V1 V1. يبقى what I'll have? I'll have 2 C1 plus C2 plus C3 times V1 plus now those for V2. V2 when? This is for V2. Yes, and this one for V2. Okay, plus C2 plus C3 V2 and then plus فضل a C3 فضل ال V3. Where is for the V3? This one alone صح? Plus C3 V3 is equal to 0. Now, since V1 and V2 and V3 are linearly independent, why? Because they are bases. Then that means this one should equal to 0 and this one should equal to 0, and this one C3 ماله should equal to 0. يبقى هيكون عندي equations. What is the first equation? It is 2C1 plus C2 plus C3 is equal to 0. And the second is C2 plus C3 is equal to 0. And the last one is C3 is equal to 0. What is this? This is a system of linear equations. How we solve? Easily طبعا we can solve from here and then we go and solve this one. But let me put it in augmented form if you like. So what I'll have, we have 2, 1, 1. And then C1 ما في term فيه C1 and C2 the coefficient حقه 1, C3 the coefficient is 1. And then the last one is 0, 0, and then 1. Correct? So this is 0, 0, 0. So this is my augmented matrix. Correct? Type it is. No need to reduce it to the echelon form because this is upper triangular. I can solve from here. So this column corresponding to C1 and this is corresponding to C2 and this is corresponding to C3. Okay, now from here, 1 times C3 is equal to 0. So what we got? We got C3 is equal to 0. Now what? I move to the second one. Type 0 of C1, 0 plus 1 في C2, that is C2, plus 1 في C3, that is C3. Okay, this is equal to 0. But C3 is equal to 0. This one is equal to 0. So C2 plus 0 is equal to 0. This implies as well C2 بتساوي 0. And lastly, we move here. What do we have? We have 2C1 plus C2 plus C3 is equal to 0. But this one is 0. And this one we found from above is 0 as well. Now that means 2C1 is equal to 0, and this implies as well C1 is equal to 0. So all the constants C1 or C2, C3 are 0. Where? So that means here, when you come back, that means what? What we got here? That this is 0. Okay, and this is 0. Only from here. C1 is 0, C2 is 0, and C3 is 0. If when letting that this is equal to 0, C1 في الفيكتور الأول, C2 second vector, C3 في third vector is equal to 0, we found that this can happen only when C1 0, C2 0, C3 0. If these three vectors, this vector and this vector and that vector are linearly independent, if they are bases as well for that vector space. يعني also these vectors, this one and this one and this one, the new vectors are bases. That means they can span this vector space as well. And they are linearly independent. Clear? ولا في سؤال؟ Clear? Is there any question? طيب. Also, طبعا I can solve it from here directly without making the augmented matrix. Why? Because from here, C3 base 0. Then when I come here, C2 plus 0 is equal to 0. That means C2 is 0. And then you move there. You have the value of C2 and C3. And then immediately you can get that C1 is equal to 0 as well. Okay? Type. Now, find a basis for W equal span these vectors. If we have a set, this is okay. This is our this is W space, okay, and it is spanned or generated by these three vectors. Right. Let's say that this is our vector space, and I have here a space. Okay, and this space is generated by this and this and this. It is a subspace, correct? If you took any vectors, يعني هنا ده في R3 with the normal addition and scalar multiplication, it is a vector space. Now I took 3 vectors, 1, 2, 3. So, and I made a linear combination. Span معناها شنو؟ معناها we made a linear combination of these 3 vectors. So, and they generate this space. يبقى it is a subspace. Okay, now he wants me to find the basis for this subspace. How can I find the basis? How can? Any idea? احنا قلنا البيزز مفروض تكون شنو؟ Linearly independent. Yeah, they span the space, but also they should be linearly independent. طيب, I have 3. Do you remember before? يعني the example that I took it that can somehow explain or make the things more clear for you. That example for the table, it's not our case, it's not typical case, but يعني it makes the things يعني almost more clear for you. Yeah, what we said. We said for this table to stand, I need مثلا a leg, for instance, here, and another leg here, another leg here, correct? And now it is, they are, you know, they are base for this table, okay? If I remove any one of them, then the table will fall, correct? So they are essential for this table, for instance, if I consider these ones. Now, what if I put more one here? It will stand as well. But this is not important, so I can remove it. Yes? So, but these are the essential. I cannot remove any one of them. Yes? If I have been given 1, 2, 3, then I need another one, 4. But this one here, it could be there, but it is extra. Yes? Type the same here when we are dealing with a vector space and subspace and things like that. Type, okay, this space can be generated by these 3, but could be one of them is not necessarily. It's enough to generate by only 2 or to generate by only 1. So I want to test, do I need all the 3 to generate this space, or some of them, they depend on the others, so I could remove them out. It is clear the idea? Type. If anyone said that I'm going to find the determinant and check that this determinant equal to 0 or no, okay? Because if the determinant is equal to 0, then they are linearly dependent. That means there is 1 or 2, I can remove them. Okay, no need for them, because that the other one, you know, مثلا, or the other 2 are enough to generate this space. Type. But again, I will not know which are the most important ones. صح؟ ده هيوريني انه okay, dependent ولا independent. Even if I calculated the C1 or C2, C3. Okay, this I can say that are they dependent or independent. But how can I know the basis? Which one are essential of these? What we do? We had it in our course. What we did? We said what? We list the vectors like that, and we try to reduce to the echelon form. The column that has leading ones, these are corresponding to the vectors that are, you know, part of the basis. And those that has no leading ones, that is, you know, that means they are dependent on the others. So I don't need them. Corresponding to those, you know, to the one that I have to remove. Okay, but if you reach to the echelon form, you reach to the identity, يعني لو وصلت ل 1 0 0 0 1 0 0 0 1 that means this is هنا leading one. ولما نيجي second row this is leading one, and here this is leading one. That means each column has a leading one. So that means all the three I need them. They are bases. They are part of the basis يعني. Okay. Oh, they give me these are the basis for my subspace. Okay. Type. Okay. Now we check what we make. We try to reduce to the echelon form. طيب هل أنا عندي هنا let us work. Okay, do the steps. Okay, now this is one. Okay, okay, so the first entry, non-zero entry, it is one. So this is the leading one. What I'll do, I make this one and this one zero. Then هيكون عندنا 1 2 5 and then 0 3 minus 2 1 6 minus 5 1 and then minus 1 plus 1. Now I am adding صح to make this one 0 here. يعني I'll make this one 0 and now I'll make this one 0. Type minus 1 plus 1 also 0 and then 1 plus 2 it is 3 and then minus 2 plus 5 it is 3 as well. Okay. Now the other thing I have to look to find the leading one here for the second, this one. So I have to make this one 0 and this one 0. But sometimes if I can simplify more, no need to go with these steps. Simplify and then after that make the things zeros. Type for me, it's more easy now. Okay, because this is 3 and this is 3 as well. If I compare these two, one of them is a multiple of the others. Then it comes to my mind to make things, our calculations more easy. I will multiply this row في minus 3 and then add. So what I'll get? So I'm going to get 1, 2, 5, 0, 1, 1, and then 0, 3, 1 في minus 3, minus 3 plus 3 is 0, and also here 0. It's clear now. Okay, I will not, because since this is all zeros, I cannot reach here. So that means I have dependent. One of these vector is a linear combination of the others. I can find it in terms of the others. Yes? Type. Okay, let's reduce to the echelon form. Do I have to reduce? Well, it's enough from here. For me, it's enough from here. This is a leading one for the first row. Here, this is the leading one. Okay, I can make easily this one 0. When I come here, this has no leading one. So it's clear that this vector, it will has no leading one. ما حيكون عنده leading one, correct? From here I can solve. If you want to continue and reach to the echelon form, it's up to you. But for me, from this step, it's clear that this one will have no leading one. Yes? Okay, Ibga, where you will have leading one? This one and this one. These columns corresponding to what they were at the beginning. They were this one and that one. Okay, so for me, it is enough to construct this one with the vectors. Which one and which one? The vector, the first vector, اللي هو 1, 1 or minus 1, and the second vector, which is 2, 3, 1. So they are the basis of this W. Okay, as a homework, go and change. Don't put them in the same ordering. يعني مثلا you can start having this one and then after that this one. You can have another زي المثال الفات. I can have different bases. These were bases, yes, but these are another bases. I can use them to construct this space. يعني ممكن تطلع لي إجابة ثانية إذا غيرت شنو؟ الاوردرنج لما جيت اعمل ليستنج. يعني هنا I listed 1 1 minus 1 1 1 minus 1 2 3. Clear? Okay, but if we use the same ordering, خلاص, these are bases. They are enough. That means this one I can write it in terms of the others. this one, I can write it in terms of this one. And if you want to do some practicing, I'll tell you one thing. Go. الquestion كان ممكن يكون is the vector 5, 6 minus 2 is a linear combination of the other vectors اللي هم, let's call them v1 and v2 of v1 and v2. Now this is a question. If you had this question, how you can solve it? How can I solve? يعني, and احنا now we found that it should be a linear combination. Okay, because this column has no leading one. Type. How can I find that it is a linear combination of this ولا لا? In this case, what we are looking for عشان to say that it is a linear combination or no? Tell me. What we are looking for? Anyone? Always, if you are asked, is that, yes, we are looking, thank you. We are looking for the C1 and the C2. Yes? Type. That is, if your vector, if this one is a linear combination of this and this, that means I can find C's, C1 and C2, such that 5, 6 minus 2 is equal to a certain constant C1 multiplied by the first vector 1, 1 minus 1 plus C2 multiplied by the second vector 2, 3, 1. So we're looking for this C1 and C2. How can I find them? What we said? We said if you expand this, you're going to find the system of linear equation. مثلا الايكويشن الأولى كانت هتكون شنو؟ 1 في C1 C1 plus 2 C2 is equal to 5, correct? From the second line you get again another equation from the set. يبقى حيكون عندنا system of linear equations. To solve it we'll put in the augmented form and we said خلاص. Instead of doing some steps like that, what we do? This part is going to be the A part في augmented matrix and this is the B part. احنا قلنا augmented matrix how it looks like. augmented matrix بيكون شكلها شنو؟ Okay. اللي هي حتكون عندنا this is the A part اللي هتكون 1 1 minus 1 and then here 2 3 1. Yeah, this is the A part بتاع الماتريك augmented matrix and then here the B اللي هي 5 6 minus 2 and then we solve, reduce to the echelon form and find the C1 and C2. So this column corresponding to C1 and this column corresponding to the C2. And you reduce to the echelon form and then find the C1 and the C2. Yes? Thank you, Sally. Clear? Okay, this is as a homework, you go and solve it. And you should find this constant C1 and C2. Because it's clear now what one of the vectors depend on the others. وحتى لو جبت determinant and another homework, go and find this determinant. مش الماتريكس, solve the determinant as an exercise for you. What do you think? A determinant المفروض تطلع بكم؟ تساوي صفر ولا لا؟ Find the determinant for this one. What do you think? A determinant المفروض تطلع بكم؟ Yeah, because what? Because they are dependent. If the determinant should equal to 0, go and solve that to make sure that they are dependent. عرفت كيف أنا dependent? When I reduce this to the echelon form. لقيت I put it in a matrix and reduced to the echelon form. I found that the column corresponding to this one has no leading one. If this vector depend on what? On this one and that one. Okay, actually that means it is, I can find it in terms of the others. That is, it is a linear combinations. So I can find C1 and I can find C2. And also, since this vector is a linear combination of this one and that one, that means if I find the determinant, it should equal to 0 because these are dependent vectors. At least one of them, I can write it in terms of the others. Clear? Clear? I'm trying to explain while I'm solving يا جماعة عشان to remind you. Clear? طيب. Question 4. Let T from R3 to في أي question في in the previous parts? Any question? Well, I move. Clear? طيب. Let T from R3 to R3 be a linear operator defined by a transformation of this vector is this. Okay, shows that this transformation, which works like that, it is a linear transformation. Type. Let me remind you, when we say that this transformation, it is a linear, it should satisfy how many conditions? 2 conditions. Can you tell me what are the 2 conditions? The first one is, can you tell me? Do you remember? Transformation. We're making the transformation from where to where? From a vector space to another vector space. Yes? يعني the transformation when it acts in any vector from here, okay, it should give you a vector there, correct? From this vector space. Yes? Actually, our vector space, the first one was R3 and the second one is R3. Yes? Type. If we have another vector, okay, let's take مثلا this one, and if I made a transformation, okay, apply the transformation on this vector, I should get another vector here. Now, since this is a vector space, then what? The addition of these 2 vectors, it should be here, correct? And as well, since this is a vector space, yes, احنا قلنا vector space has 10 conditions should be satisfied. 5 with respect to the addition and 5 with respect to the scalar multiplication, correct? طيب. The 5. Okay, one of these 5 is what? It should be closed under addition. That means if I added this one to this one, the resultant should be here available. And also, if I add this to this one, also the addition should be here. Correct? Then what he said? He said to be a linear transformation, then the transformation of the vector x plus y, that is the transformation of this element, should be the same as getting this one, اللي هو transformation of x alone, and add to it a transformation of y. Okay, so the addition of this, which is this one. So this one should be mapped to that one. Clear? So this is the first thing, that if the transformation is linear, so this condition should be satisfied. Okay, what's the second condition? The second condition, also, since this is what a vector space, then what? Then if we have this element, then we should have this one, which is what? Constant, a real number, let's call it C1, multiplied by this vector here. Let's call it مثلا X1. Okay, so it should be here. Yeah, this is one of the 10 conditions. طيب, okay, and also since this is a vector space, okay, if we have this element here, then this element times C, it should be here as well. So we should have مثلا let's C1, okay, it's same C1 في مثلا Y1 as well. طيب, now what is the statement of the theorem? The theorem is that the transformation of C1 في الفيكتور X1 is the same as this one, which is this one, okay? If we want the transformation of it, is the same as the transformation of X1, which is this one, and then we multiplied by C1. Okay, so this one, when we multiplied by C1, هتيني this one here. So that means this one should be transformed to this one here. So if these two conditions are satisfied, your transformation is a linear transformation. And we said we can prove like that, or we can do the two steps in one step. Instead of having two like this, we can do an addition. We prove the condition for the addition and for the scalar multiplication in one step. So transformation of what? Let's say C phi x plus y. I just multiplied one of the hands by C, or one of the vectors by C. This should equal to C phi transformation of x plus the transformation of y. If we did this, we proved this, خلاص, enough. That means we proved that and proved that one. Clear? طيب, now let's prove. We want to prove that this kind of transformation, how it works, this transformation. It works like that. Transformation of a vector x, y, z. The first is what? First minus the second, x minus y. And then the second element is this minus that, y minus x. And then the last one as it is. Okay? Okay. Now, let's prove what always we do. We take two elements from the first set like that. Yes? And then find their addition. Okay? And then find the transformation. Type. Let's take two elements. مثلا here we assume that we took x, y, z, or x dash, y dash, z dash. Let's assume we took these two vectors. I can take x, y, z وهنا x dash, y dash, z dash, أو x1, x2, x3 وهنا أقول y1, y2, y3 where x1, x2, x3, y1, y are real numbers and etc. Clear? Or any naming. Type. And then what we need? We need, if I'm going, always I've been using this way. Now let me prove for you using this way. Okay, as he did here. Type. Let's work together. What we do, we multiply first vector by a constant and this one as it is, and then we do the addition. And then after we find the transformation of this vector, new vector. So what I'm going to get? So we need the transformation of the first vector, can x, y, z, multiplied by c. So c multiplied by the vector x, y, z, plus the second vector اللي هو x dash, y dash, z dash, اللي هو second vector اللي هو x dash, y dash, z dash. We need to find this transformation. So how we find this transformation? First, we have to simplify this. When you simplify, you are going to get c x plus x dash. This is the first component. So transformation, we need to find the transformation now of which new vector? Of the vector c x plus x dash. And then second element اللي هو شنو? y plus y dash, cy, sorry, plus y dash, correct? And then the last one is cz plus z dash. Yes, so this is our vector, okay, and we need to find this transformation type. Now we come and test how the transformation work. First minus the second. So what's your first? This is my first. And what is your second? This is my second, correct? So first minus second. So this is equal to cx plus x dash minus this. So minus cy minus y dash. طيب what about the second element? How we get it? اللي هو second minus the first. So this is the second. اللي هو هيكون شنو؟ cy plus y dash minus الفيرست اللي هو minus cx minus x dash. طيب what about the third element? It is as it is. طيب اللي هو شنو؟ cz plus z dash. Okay, now this is the vector I'm getting. Okay, I reach here. طيب, but what is that? Where we want to reach? I want to separate the first vector alone with second vector alone. I'm testing that. This is what I'm putting in my mind. So that is, I'll take the one that has a dash alone and that has this alone. Yeah, this vector, I can write it as an addition of two vectors. What is the first vector? It is the vector cx minus cy. طيب, plus the second vector, which is what? X dash minus y dash. Now we do the same here. So cy, correct? Minus cx. And then here, y dash minus x dash. And then the last, here we can put cz, and here we can put, z dash. Yes, so this vector plus this vector. But now from this one, I can remove the c and take it as, a common factor. صح؟ لأنه each term is multiplied by this c. So I can put the c outside and remove it from here. So c multiplied by the vector. Yes, so I'm going to get this, my vector, like that, multiplied by c. But what is this? X minus y, y minus x, and then here z. Come on, check here. What is this? It is the transformation of that vector. So this one, actually, it is c times the transformation of the vector x, y, and z. Plus, what is this? X minus y. So this is the transformation of x dash, y dash, z dash. If you applied this one, what you are going to get? I'm going to get this one. So did I reach? Yes, I reach. So the transformation of the first plus the transformation of the y, c multiplied by. So that means, yes, it is true that your transformation is linear transformation. Clear? Do you have any further question? Or it's clear؟ بالنسبة للبارت A هل في question تاني؟ طيب. Describe R of T. What is the meaning of R of T? What he means by R of T? R of T, that means the range of this transformation. Before we had the transformations, correct? The range and the null space, correct? طيب how we define the range? Okay, we said that if we have هنا a vector space and here a vector space. Okay, and we defined a linear transformation that goes from here to there. Okay, if we want the range, that means what? We need all the images of the elements here. If you have here some elements, okay, so for instance, this element, it maps to here, and this element, let's say, map to there, and etc. So it could give me, though I am considering all the elements here, it could give me all the elements here or part of them. Type, if it is part of or if it is all, I need that set. And this set, we call it the range of the transformation T. That means it is the set of what? The set of all the images. For which set? For this set. الصور دايما بنسميها صورة. When you act on one and then you get one here, so the one you're getting, we call it images. So we need the set of all images. طيب. But a map is defined from where to where? From R3 to R3. صح في example above. في البارت above at the part في question. A transformation, it is from R3 to R3 and it is a linear transformation. Okay? And now he's asking me to find this R of T, the range, اللي هو a set of the images. Which is it, this part only or all this R3? طيب. How can I find it? Am I going to test all the elements here? اخد مثلا element 0 0 0 واشوف الايمج حقه 0 1 0 0 1 0 0 1 and whatever. I'll never end up. So what is that set? How can I get it? I am in R3. And in R3, I knew that I can find any element in R3 by doing a linear combination for its spaces. And we knew as a theorem that for R3, I need what? I need 3 linearly independent vectors. Any 3 linearly independent vectors can doing linear combination of them will give me the whole R3 of every element in R3. So R3 is spanned or generated by 3 linearly independent vectors. In particular, what we knew that 1 0 0 and the vector, the second vector 0 1 0 and the vector 0 0 1, it's clear they are linearly independent. If you find the determinant for this, you will find that it is what? It's not equal to 0, so it's linearly independent. And these are the trivial. صح؟ Okay? اللي هم الunit vectors. طيب. So I can construct all R3 using these 3 vectors. We had it before. Okay, by doing what? By doing a linear combination. That is C1 for this one. Yani for instance, if I need any vector X, Y, Z, or C1, C2, C3. So just this is multiplied by X because 1 في X هتديني X الفوق. And then here by Y, I'll Y here. So I'll get this Y when I am adding this to this, correct? And this is phi Z. Clear? Yeah. So any vector, I can get it in terms of this. And this is very easy and very clear. Type. So يبقى R3 is what is generated, sorry, R3 is generated or spanned by these 3 vectors. So that is R3 we knew إنه is equal to span what? This set of vectors. It is spanned by these 3 vectors by doing a linear combination for them. We write it like that بدل ما أكتب C1 في this vector plus C2. We can write it like that. طيب now اوكي ما في مشكلة. طيب اوكي يا رزان. طيب now what I need the transformation for each and every element here. So this is how we can find it. This is we can finding by finding a transformation for all the elements here. Okay, for all the elements here. Let me. So we need the transformation of what? For all, for each and every element. So we need it for span, this for the linear combination if of this set, كل ال possible linear combinations. طيب okay. What do we have? We have that our transformation is a linear transformation. يعني what do we have? We have مثلا transformation of the vector C1 في X plus C2 في Y is the same as C1 T of X, correct? Because the transformation is linear, C2 T of Y. Yes, and the span معناها linear combination, just like that. So that means I can do the addition after the transformation. And also I can do the multiplication after, by the constant after doing the linear combination. That means this is, we can always write it as, since the transformation is linear, this we can write it like the span of what? Of a transformation of the vectors 1, 0, 0, a transformation of 0, 1, 0, and the transformation of what? 0, 0, 1. And I told you always, if you want to find a range, just use this like a theorem. Look at your space. If R3, you need 3. 1, 2, 3. If R4, so you need 4. So there is a fourth one. And then here 1, 0, 0, and then again 0, 0, 1, 0, and then and etc. And then write the last one, which is going to be 0, 0, 0, 1, and etc. Correct? And then you do the same. 5, so you need 5, 7, 18, 19, 100, whatever. Is it clear? So ibga, above I explained to you how things are going, but now we can just start from here. What is the range? Describe, that means find, as simply as that. Okay, so we are finding the range of T. How we find it? Just find the span of this, because I am in R3, I'm from R3 to R3. So from R3 خلاص هعمل span of this. Okay, sorry, you have to look طبعا and yeah, this is R3, so you do like that. Type. Now we apply the rule. This is equal to span what? How you transform the vector? We go and check how the things are working, how it is working. First minus the second, then second minus the first, and the last as it is, correct? So you apply it here. So this is span of what? A vector. Now the first one is going to be 1 minus 0, so 1, and then 0 minus 1, so minus 1, and then the last one as it is. So this is the first vector. And you do the same, you find the second, do the transformation. So first minus the second, so minus 1, and then second minus the first, so it is 1, and then the last one, it is 0, and you do the same to find the last one, 0 minus 0, 0, 0 minus 0, 0, and the last one as it is. So what is your range? My range is spanned by these three vectors. طيب احنا قلنا احنا we are in R3. Yes, so and we have 3. So هل any 3 will give you the whole R3 and it's not a part you so the range all this set or no? How can I know? Tell me. How I can know? How can I know that all R3 will apart from R3? Huh? How can I? You can go, Laya. How can I? جماعة لازم نذاكر، امتحانات خلاص قربت. طيب. Not any 3. They should be linearly independent عشان to construct the whole R3. لازم يكونوا bases. طب how can I know هم bases ولا not a bases? What we do? إنهم هم bases ولا لا? Are they linearly independent or no? طيب. But I don't want only هم الثلاثة linearly independent or no. I want to know which one, if they are linearly dependent, which one I should remove. So to do this, it's easier just to put it in a matrix 1, minus 1, 0, minus 1, 1, and 0, and then, yes, to find the leading one as we did before, like that. Type if we now we reduce to the echelon form, so this is 1, correct? I put the other 0. Type this هيبقى شنو? We add R2 to R1, so we'll have 1 minus 1 and then 0, and here is going to be 0, and then 1 minus 1, again 0, 0 plus 0, 0, and the last one 0, 0, 1. And then after what we do, take this one down, so what I'll get? 1 minus 1, 0, and then 0, 0, 1, and lastly 0, 0, 0. Yes. Type, this is the leading one here, and then this one, this is the leading one. The last one, no leading one. يبقى what? We have this column has leading one, and this column has leading one, while this one has no leading one. That means this vector, I can write it in terms of the others too, in the other two. So these are linearly dependent, since this one is a linear combination of the others. يبقى not all the 3 are bases. To construct this space, when this space here, I need only 2 vectors, which are this one كان في الأول شنو? This one. And now this one, which one? This one. So these 2 are enough to construct your space. It is not all R3, but part from it. Part of it that is generated by this vector and that vector. Part of it that is generated by this vector and that vector. Clear? يبقى describe RT. RT is span 1 minus 1 0 و the vector 0 0 1. Yeah, it is like that here. خلاص, it is spanned by this vector and this vector. So this is your set. Not all the 3. Not all the 3. لو كان كل الثلاثة 3 vectors linearly independent, يبقى they will give me all R3 كان حيكون all the space there. Clear? Clear? Any question for now? طيب. Find the basis for the null space of T. طيب احنا before we knew what is the range. Now what is the null space? Null space, if I have this is a vector space and this is another vector space, and I have a linear transformation that goes from here to there, I need the elements here that what? That all will map only to the zero element here. So the map here, what should be the zero element. I don't need the others. Here, I don't need, but all from here. So it is where it is in this space. إذا لو كان هنا مثلا from V to W. So I need, apart from this, the first one, the V, that all its elements are going to map to the zero element here. Clear? So I need this set. طيب الانفورميشن اللي عندي شنو؟ The map here is the zero. طيب how the transformation was, it is this set here, correct? It is this set here. Okay, so this should equal to 0, 0, 0. Yes, if what I'll have, I'll get a system of linear equation. What is the first equation? X minus y is equal to 0. Second, y minus x بتساوي 0. The last, z بتساوي 0. And then solve for x and y and z. If you find the x and y and z, that means you find all the elements here, how they look like. What's the relation between the x and y with z? Clear? طيب, let's do it actually, to gain time. Okay. طيب. So as I told you, x minus y بتساوي 0, y minus x is 0, z بتساوي 0, because I want the map with a 0 here. So when this will be 0 and this is 0 and this is 0. So I have a system of linear equations, put them in the augmented form. So this is the augmented form, because 1 and then 0 and then 0. صح؟ اللي هو sorry, x minus x و 0. So 1 minus 1 and 0 وهكذا. So you do this and then reduce to the echelon form. When you reduce to the echelon form, you're going to get this one. Okay? طيب. Now, what is your x? What is your y? What is your z? أول حاجة, the system has solution or no solution? It has solution. How many number of solution? Unique ولا infinitely many? Infinitely many. Why? Because how many number of leading ones? عندي كم leading one? How many a number of leading ones? Only 2, correct? So here, this is the first leading one. Here, the second leading one, and the last one has no leading one. If get 2, if get infinitely many solution, and this one, what we call it? We call it هو ده كان حق x corresponding, and this is corresponding to the y, and this is corresponding to the z. So what we do? ما عنده leading one اللي هو y. We let y is equal to t, and then solve, correct? طيب. y بتساوي t، يبقى حيكون عندنا شنو؟ x minus t plus 0z is equal to 0. That is x بتساوي t, and then we had y is equal to t. And lastly, what about the z? We come here from this equation, 0x plus 0y plus 1 في z بz, z بتساوي 0. يبقى what is your solution? It is the set, okay, of vectors. If you want, ممكن تكتبها t0 such that t belong to R. Or you can write it as t multiplied by 1, 1, 0. This is your vector that will generate your space such that t belong to R, because all the vectors will look like that. So this is your set, okay, that the element that look like this will be mapped to the 0 element. How they look like? Give me one example. Give me one of these vectors. اديني مثال لواحد من الفيكتورز دي. طيب, if I took t by 2 هيكون 2 2 0. طيب, apply the transformation to make sure that you did it correctly. Transformation, how it works? We said first minus the second, so it is 0. Second minus the first, so it is 0. And the last as it is, so it is 0. Yeah, it is correct. And for any number, even if you took half, 0, if you took square root of 3, square root of 3, 0, all they will map. So all the elements like that, they will map to the 0. So this is my null space. يبقى the null space is the set of vectors that look like, here he did a mistake. It's not -1, it is 1. This is wrong. -1, it is 1. Okay, so what is this? This is a span of what vector? Of the vector 1, 1, 0. Because any real number, just time this. So you'll get your set. Okay, anyway, so the null space n of t, okay, it is the set ده to set اللي هو span of the vector -1, 1, 0. Only one vector. Span of it. Linear combination of that one. That means just you multiplied by a constant. It will give you all this space here. Okay? طيب هو he don't want this خلاص null space. He need the basis. Okay, so only I have one vector. So أكيد ما حفتش إنه linearly dependent ولا independent عشان to be dependent كيف ولا إيه. Okay, so it's only this vector. So it is the basis. So this is the basis for your space. You can generate this space using this vector by multiplying it by any real number. Clear? Okay. Type the last question. Do you remember the eigenvalues well eigenvector? The last chapter. Type. We defined an eigenvalue or eigenvector. How we defined it? We said if we have a square matrix X, m by n, 2 by 2, 3 by 3, 5 by 5, whatever, any kind of matrix, but a square matrix. Okay, and you find a non-zero vector X such that A times this vector is the same as a real number lambda. Real number lambda da representation for a real number, not a vector, not a matrix, a real number times this vector X. So if you could find this X and this real number, then what we say this one, we call it what? The eigen value. And we call this X, which is the same as this X, we call it the eigen, vector. So is it clear? What is the eigenvalue? What is the eigenvector? Okay. Now, we knew that if I need the eigenvalue, how can I find it? What we did? We put this all in one hand. So I have lambda x minus, yes, thank you, by the characteristic equation, yes, Ali. Type ax, lambda x minus ax, and this is equal to 0. And then that means the determinant of this hand is equal to the determinant of this. So the determinant of this of zero vector, zero matrix, يكون عندك matrix كلها zero, determinant حقتها شنو? It is 0. طيب. So that means lambda I, take the x as a common factor. Lambda I minus a, okay, phi x, this determinant is equal to 0. And this x, we said from the beginning, it's not a 0 vector. So this x is not equal to 0. So to have this determinant equal to 0, the only way out in this part should equal to 0. يبقى حيكون عندنا شنو؟ lambda I minus a, this determinant should equal to 0. So and احنا determinant always it is what either a real number, value, one value. But since here I have lambda, so I have, it's going to be an equation in terms of what? In terms of lambda. And this equation, we call it what? The characteristic equation. We call it what? The characteristic equation. Clear? طيب. يبقى this one we needed to find what? Your lambda. يبقى always if I want to find the eigenvalue from where I start, from the characteristic equation, you put this and then you start solving. طيب how to get the characteristic equation? You have the A. So I have the A here. صح؟ لاحظ الماتريكس لازم تكون square matrix. This is 3 by 3 matrix. So what is your I? الايدنتيتي هيكون which one؟ اللي هي الدايمنشن حقها 3 by 3. So هعمل شنو؟ lambda just times the I اللي هو هيكون 1 0 0 0 1 0 0 0 1. You multiply and then minus this one and then find the determinant for the new matrix. How you proceed? Lambda you multiply it by this ones. يبقى هنا هتظهر lambda في 0 ب 0 في 0 ب 0 في 0, correct? And here as well lambda and here as well lambda. Okay? So this is going to be your matrix. So this matrix minus this one هتديني شنو? What it will get, what I'll get? Lambda minus 1. So it's going to be lambda plus 1. So this is your lambda plus 1. And then 0 minus 0, it's 0. And 0 minus 0, also 0. And then etc. 0 minus 0, it is 0, correct? And then lambda minus 1. So this is lambda minus 1 and etc. And you complete. Now what? I need to calculate the determinant of that because this is the characteristic equation and equate it with 0 here. So this one, how we can find the determinant for this matrix? We can expand using what? Or find the determinant using the first row. لأنه this one 0, this 0. It will make the calculations more easy. So this is going to be what? What is the value? Lambda plus 1 multiplied by, you do like that, and then open the bracket. Or just time what determinant? You take this away and this away. So your determinant of lambda minus 1, and then here minus 2, and then here 0, and here lambda. So this time this one, which is equal to lambda plus 1, correct? Time what? This times that minus this time this, correct? يبقى lambda minus 1 في lambda, correct? Minus 2 في 0 ب 0, correct? يبقى minus 0. So this part خلاص, it's not there. يبقى what I'll have? I'll end up by lambda plus 1 في lambda minus 1 في lambda is equal to 0. Type, and this is just multiplication of terms. So to be equal to 0, so either this one is 0, or this one is 0, or this one is 0. Correct? That means either lambda is equal to minus 1, or 1, or 0. يبقى what are the eigenvalues? These are the eigenvalues. يبقى eigenvalues هم مشنو؟ minus 1, 1, و 0. يبقى for this matrix, the corresponding eigenvalues are minus 1, or 1, and 0. Now, how can I get the eigenvectors? He asked me here to find the eigenvalues. If you need the eigenvectors, how you can get it? I tell you. I don't need the characteristic equation. Actually, this I get it from where? I get it from this one. This was a matrix, correct? So this matrix is equal to 0. So I don't need the determinant. I need the matrix lambda I minus A في X بتساوي 0. Okay, so that is what. Okay, that is what. This is a matrix and this is a vector and equal to 0. So a matrix times the vector x اللي هو حيكون هنا لأنه عندي 3 by 3. So كأنه x, y, z. This is equal to 0, 0, 0. يبقى حيكون عندي system of linear equations, correct? And I can solve if I know the lambda. But I know the lambda. Okay, so for each lambda here, when you substitute with, you are going to find what? A corresponding eigenvector. يبقى the first time you will substitute here by lambda بتساوي minus 1 and then you solve and then you get the solution, the corresponding eigenvector. Second time you come and substitute in the same here في محل اللامدا بكم ب1 and then find another corresponding eigenvector and etc. This is how you can find the eigenvectors. Clear? طيب let's do some. Okay. يبقى if this is دي اللي هي كانت الديترمينانت اللي هي الجي بتاعها الثابته من هنا. I need this part but in a matrix not in a determinant. Correct? So I come just and substitute here. Okay. طيب the first time to get the corresponding eigenvector I am going to substitute by come take lambda 1 مثلا is equal to, let's take مثلا minus 1. Okay, so I substitute فيها to matrix في الماتريكس اللي هي حتكون this one lambda plus 1 0 0 this one. Okay, and I will reach to this form and to solve this form we put it في augmented as an augmented matrix. Correct? Let me do it here طوالي. So this one augmented matrix هنا حيكون عندنا this part, this is the B 0 0 0 like that. طيب let's find this part بتاع A from here. Put lambda اللي هي minus 1 هي حتكون شنو؟ minus 1 plus 1 so 0 and this is 0 0 and here 0 and then put minus 1 minus 1 minus 1 so it is minus 2, correct? And this one here minus 2 and lastly minus 1 0 and the lambda minus 1 so this is minus 1. يبقى now I want to solve this شنو system of linear equation. I put it already في augmented form and I am solving for what? For the x, well y with z to get the vector x, y, z which is the eigenvector corresponding to this eigenvalue. Okay, so how you proceed, you know how to proceed, correct? What we do, we exchange this one by this one, R2, R1, or R3. So what you will have, I'll have minus 1, 0, minus 1, for instance, and then 0, minus 2, minus 2, and then here 0, 0, 0, correct? And this one here 0, 0, 0, and etc. Reduce to the echelon form. Type here, this it should be a leading one, so I multiply by minus sign. Okay, and then after that I'm working with matrices not determinant ها عشان تقول لي الماينس sign حتفرق ولا. Okay, طيب for solving the linear system. طيب and then يبقى حيكون عندنا شنو؟ This is your leading one, correct? And the others are zeros. Now here we make this is a leading one. Type to make it a leading one, what we do? We divide this row by minus 1 over 2. So what I reach, I'll have 1 0 1 and then 0 1 1 and then the last one 0 0 0 and then here 0 0 0. Okay, so this is the first leading one. At the others below it zeros, and this is for second row This is the leading one, and this one is 0 and 0. And if I reach here, all zeros, no leading one. IBGA, is it in the reduced echelon form? Yes, it is in the reduced echelon form. How many solutions are there? Infinitely many number of solutions, because the number of leading one is less than the number of unknown. So I can proceed and solve. This is corresponding to X, this is Y, and this is Z. Type. يبقى حيكون what is the solution? From the first row, أول حاجة we let Z equal to what? To T. صح؟ لأنه this column has no leading one. Z بتساوي T. يبقى what is the solution? X plus Z is equal to 0, but the Z is equal to T. That is X plus T equal to 0, and that implies the X is equal to minus T. Type. And now from the second row, Y برضو plus T is equal to 0. That is the Y is equal to minus T. And lastly, we assume that the Z is equal to T. So that is, we got the vector XYZ اللي هو minus T, and then T. Take the T out. So this is equal to T multiplied by minus 1, minus 1, 1. What is the corresponding eigenvector? The corresponding eigenvector is this one. For what? For lambda is equal to minus 1. Clear? طيب لو كان عايز الايجن سبيس كنت هاخد دي كله like this or just like that. لكن عايز الايجن vector, so this is the corresponding eigenvector. And then after you do the same for the case lambda بتساوي شنو؟ lambda بتساوي 0. يعني next time you substitute 0 where? In the matrix بدل minus 1. Okay? محل اللامدا. And then you go and solve and find this and etc. Okay? So this is if you need the eigenvectors. Here he didn't. He asked only about the eigenvalues. Clear? Type. Part B. He is asking find a non-singular matrix P and a diagonal matrix D such that D بتساوي P inverse في A في P. Let me remind you with our last class. Okay? Type. What do we have? In our last class, we had two matrices, matrix B and matrix A. We say that these two matrices are similar if we could find a matrix P that has an inverse P inverse, and when we multiply this P inverse phi A phi P with this order, we get this P. So if A and B are similar, the most important things that they have the same eigenvalues. They will have the same eigenvalues. That means this eigenvalue of this matrix is the same as the eigenvalue of that one. First. Second, if we have A and B are similar matrices, that means exist P. وطبعا exist the P inverse. طيب, if one of these is diagonal, or this one, let's assume لو B diagonal, we say that the matrix A is diagonalizable. If B is diagonal, we say A is diagonalizable. Clear? الماتريكس اللي بتطلع B لو diagonal دي هنسميه A diagonalizable. طيب, what is the importance of the matrix to be diagonal? If the matrix is diagonal, easily you can find what the eigenvalues حقتها. كل الماتريكس if it is diagonal or upper triangular أو lower triangular, in particular لو كانت diagonal, then the elements that are in the diagonal are the eigenvalues for it. يعني هنا لو كان في diagonal مثلا 2 minus 3 4 for instance. So what are وهنا all the elements here zeros and here zeros, and he is asking me to find the eigenvalues. Just you will write, no need to go in steps like before. Just immediately it is 2 minus 3 and 4. Clear? يبقى لو كانت الماتريكس diagonal, what are the eigenvalues? These are the eigenvalues. طيب, if it is diagonal and these are the eigenvalues. So what are the eigenvalues of A? No need to calculate. It is 2 minus 3 or 4. Why? Because they are similar. Okay? طيب, just 5 minutes and we'll stop. طيب. Now, خلاص, you're reminded with the eigenvalues and the eigenvectors. طيب, from where we get this B? What we had? What is P? P actually, it's what for this matrix A, find the eigenvectors. Find what? Its eigenvectors. Like here, اللي هو this one, the first one. And here we are going to have 3, correct? Eigenvectors. Put them in a matrix like this. So this is the first vector you get. مثلا this one. Okay, اللي هو what we got, minus 1, minus 1, 1. And then the second vector you put here, and the third corresponding to the lambda بتساوي 0, you put them like that. So this is going to be your P. Okay, and then find the P inverse. And then if you multiply it, you're going to get this one here. So is it clear from where you will get the P? P is just that it is the eigenvectors. الcolumns حقتها هم eigenvectors of A. طيب, هل always I can find this diagonal matrix or no? No, not always. Only if these are linearly independent. حتى لو كانوا ما independent كان هتقدر تجيب ال P inverse؟ No. Okay? يبقى what? يعني you cannot diagonalize the matrix unless its eigenvectors are what? Are linearly independent. No one of them is a linear combination of the others. So if you find that these are linearly independent, immediately, yes, A is diagonalizable, okay? And if you want to get the diagonal matrix, immediately, no need to go in steps to find it. Since this is diagonal, check what is the eigenvalue for this. This vector, eigenvector is corresponding to what? لقيناه to minus 1. Just put minus 1. Let's say that this was corresponding to 1. So put the other element في diagonal 1. And the last one is corresponding to 0. So the last element في diagonal is going to be 0, like that. And then here 0, 0. And then this is 0 and 0. The other طبعا لأنها هي diagonal matrix. Is it clear how you got the B? Okay, and how you got this one, a B matrix? Okay, let's see. Find a non-singular matrix P. Non-singular معناه independent. معناه he told you that this eigenvalues are going to give me at the end 3 linearly independent vectors. No need to test them because he said that P is going to be non-singular. He told me that. The one you are going to get, clearly, you know, it is non-singular. Oh, he gave me that, it is non-singular. يبقى the vectors that I'm going to get, they are linearly independent. يبقى this one, this matrix, the one I started with, is diagonalizable. And I need as well to find the diagonal matrix. So what I'll do, I have to find all because P, he need me to find P. So I need to calculate the 3 eigenvectors. So we found one. You do the same to find the other 2. Okay, here I believe he found the other 2. Let me see. Okay, so he did, this is lambda minus I, and he started solving. So he get, this is 1 vector, this is the other vector, and this is the same as ours here. Clear? Ibga, what you do? Take them and put them in a matrix form like that. So this is your P. For some student, for them, if they started with this هيكون هنا and this here, and ما في مشكلة, no problem. Clear? يبقى anyway, this is take the columns, put them الvectors, eigenvectors, put them as columns in this matrix. So this matrix is P. Now, if he wants you to find D, what you do? Because he told me that it is a matrix P is singular, it is non-singular. That means what? No need to test what you got. You're quite sure that it is, you know, it is non-singular. That means a P inverse exists. That means when you multiply A from the left-hand side by P inverse and the right-hand side by P, you're going to get D. Type. What is D? Should I go and make calculations P inverse phi A phi P? No. Already before I calculated the eigenvalues اللي هم طلعوا شنو؟ -1 و0 و1. طيب this one طلع لي حق -1. Correct? If you checked here, this is حق -1. Okay? And here when he substituted ب0 في السكند. وفي الفirst when he substituted by 1. So ابقى immediately this is equal to D. What is your D? Just the first column can corresponding لشنو? Can corresponding ل 1. Put 1. A second column can corresponding ل which eigenvalue? Can corresponding to 0. Put 0. And the last one corresponding to -1. And then so this is your D. So no need to go and waste time and calculate it like that. You should get this one. Clear? Since he gave me the 6, خلاص, and he told me that B is non-singular, خلاص, يبقى this one exists and it is diagonal and these are going to be the eigenvalues. So is it clear? Any question? Any question or it's clear? If you have no question, we can stop here. We stop here.